Find and state the nature of the stationary points of y is equal to x cubed minus 2x squared minus 15x plus 4. Now, if we just look at this in a program called GeoGebra, you can look at this after yourself later. Okay, if we got the here we got the curve, okay, and here we got a point on the curve, and we've got the blue line here, which is a tangent to the curve, which represents the gradient of the curve at that particular point. Now, if we move the slider, we can see it moves like that. Okay. Now, stationary points is where the gradient will be actually horizontal, which is about there. Okay, and that's our local maximum, and this one here is a local minimum. Okay, you can also get stationary points which are points of inflection, which we're not going to look up in this particular example. Okay, so we've got that applet there for you to have a look at. Right, so we've got y is equal to x cubed minus 2x squared minus 15x plus 4. If we want to find the gradient function, we need to differentiate this, and we know the differential of ax to the n is equal to anx to the n minus 1. So differentiating term by term, that's going to become 3x squared minus 4x minus 15, and when you differentiate 4, you get nothing. To locate stationary values, the tangent needs to be horizontal, i.e. dy by dx has to be equal to 0. So we put this, and we put it equal to 0. So we've got 3x squared minus 4x minus 15 is equal to 0. Now, it depends on your ability to solve a quadratic. One way to do it is to say the product is 3 times the last number, which is minus 15, which gives you minus 45. The sum will be minus 4. And you ask yourself this question: what two numbers, when you multiply them together, you get minus 45, and you add the same two numbers, you get minus 4. These are called the factors, and the answer is going to be minus 9 and 5. We can do a little check on that. Minus 9, the product, times 5 is minus 45, so that's agreed. And if we add the same two numbers, minus 5 plus 45 is minus 4, so that's agreed. Therefore, this is correct. So what we do, we take the quadratic now, and we split the middle term up into minus 9x plus 5x, which makes all together minus 4x. So we're not changing the meaning. So we've got 3x squared minus 9x plus 5x minus 15 is equal to 0. A word of point here, these two can be in any order, it doesn't matter. Right, and then you do what's known as factorizing by grouping. So there's a common factor here of 3x, so that comes out, and what's left in the bracket is get x minus 3. Plus, when you group the next two terms together, the common factor of 5 here, so you take that out, and you're left with x minus 3 is equal to 0. Now you can see, now you have a common factor of x minus 3 in both things. You've done this, these two brackets will always be the same. So that can now come out, and you'll be left with 3x plus 5. So you've got x minus 3, 3x plus 5. So either x is equal to 3, or x will be equal to minus 5 over 3. To test the nature of the, you use the second derivative, so you differentiate this again. So it's going to be the second derivative, which we write like this. So it's going to be equal to 6x minus 4. So when x is equal to minus 5 over 3, we put that in there, we get 6 times minus 5 over 3 minus 4. The 3 and the 6 will cancel. Now we only need to be interested in the sign. We're going to have minus 10 minus 4, which is definitely negative, therefore that point is a maximum. The only point of be careful, it actually is equal to 0, because if it's equal to 0, you have to go back and use what's known as the first derivative test. When x is equal to 3, the second derivative will be 6 times 3 minus 4. We can definitely see that's positive, therefore that's a minimum. So the last thing we need to do is find the y coordinates. So in order to do that, we need to use the y Okay, so using y and then substituting in first, when when x is equal to minus 5 over 3, we substitute in minus 5 over 3 cubed minus 2 times minus 5 over 3 squared minus 15 times minus 5 over 3 plus 4. Right, if we need to cube this, we get minus 125 over 27. Minus 5 squared is 25, so we get it minus 2 times 25 over 9. Here, the 3 and the 15 will cancel, so we get 5 times minus 5 times 5, which is plus 25, plus 4. So this is going to give me 125 over 27. 2 times 25 is 50, but we want to put it over 27 as well, so it's going to be 150 over 27 plus 29, which is 25 plus 4. That's going to give me minus 275 over 27, and I'm afraid 29 becomes 783 over 27, which gives me 508 over 27. When x is equal to 3, this is a bit easier, got 3 cubed minus 2 times 3 squared minus 15 times 3 plus 4, which is 27 minus 18 minus 45 plus 4, which is minus 32. So in conclusion, the maximum at minus 5 over 3, 508 over 27, and a minimum at 3 minus 32. Okay, now in order to do, if it was a calculator question, you could use the TI and the Spire. So you need to select graphing mode, which is this one here. Okay, and put in the functions as x hat cubed arrow minus 2x squared minus 15x plus 4. Enter. That's not a very good viewing window, so we're going to set a decent viewing window. You can work this out for yourself. Menu, window zoom, window settings, and I'm going to use minus 4, 6 on the x, so minus 4 to 6 on the x, and then from the y, minus 35, and the maximum I'm going to be 20. Press OK. That gives me a much better view window. It's going to be the label up there. Now, to find the maximum and the minimum using the calculator, okay, so it's menu, analyze the graph number 6, go for the maximum first, number 3 maximum. So go slightly to the left of it and then go to the right, and it'll give you the coordinates. Okay, and again, menu, have to repeat again, number 6, analyze the graph, minimum point to the left and to the right, and we get the minus 3 over minus 32. Okay, so if you were going to do that on your exam script, you'd have to actually draw that graph and show it that way if it was a paper 2 type question. So to finish off with, just a screenshot of what I've just done there.